Welcome to the tutorial Particle Effect Modules and Templates Part 1. So to be honest with you, in this tutorial I'm going to talk more about the modules than I will about the templates, but that's just because I think the modules are best described when seen in context. However, for the second part, I will definitely talk more about the templates than I will about the modules. So what we see here in the network view and what I use for the first tutorial is actually a template. And templates are great because you can use them to analyze their structure so that you can then learn to build your own particle effect systems. So there are two ways that you can access the particle effect templates. The first way is through the insert menu here at the top. You could go to Insert, Particle, and all the particle system templates are listed here. So the one that we currently see in the network view is actually this one, the basic particle system. The second one that I'd like to take a look at is the basic gravity-based system. And the difference between inserting a template this way, so I'm going to do it this way, is that now this basic gravity system has automatically been connected to the composite of your scene. Whereas if we go into the module library, which is the second way of accessing particle effect templates, and let's look for the tab first. There we go, particle examples. If I took the same one, which is this basic gravity based, and I drag it and I drop it, you can see that it actually has not been connected and that I would then have to connect this myself to make it appear. So let me just expand the network view for a minute to clean things up a bit. So this is the gravity-based system that I just connected, and I'm actually going to delete it because we don't need to. And I'm going to select all the modules of the basic particle system and delete those as well. And lastly, I'm going to drag this down here. In this case, the peg is at the exterior of the group, but the basic gravity-based system has been grouped. And if we go inside, we can actually see the system. So let's also keep the camera view open so we can see what this looks like. So unlike the basic particle effects system, where everything was being generated from a rectangle, this one looks a little bit different. It actually looks like salt pouring out of a box, or maybe snow blowing out of a snowblower machine. And so there are a few new types of modules here that we haven't seen before. But I'm not going to go into detail about these modules. I just want to talk about the ordering, first of all, of these action modules, which is what we're primarily going to be concerned with. So here we have the emitter, which if you remember is pretty important because this is what emits the particles. So I'm going to go through and disconnect everything around the emitter, and you can see what role they play in the emission of these particles. So for example, right now the emitter is being emitted from a 3D region. So we'd like to see what that 3D region looks like. So I can select the 3D region, and then I can go to the top here and select View, Show, Control. And there's actually one more thing I'd like to show you from the View menu that I forgot to mention in the previous tutorial. If you go to the View menu, you can also select Particle, Show Particles as Dots in OpenGL. And this is another way of forcing the render to be dots no matter what you have as your sprite. And if you remember in the particle visualizer, you have the same option, force to render as dots. So I just wanted to mention that as a side note. Well, let's go back to the emitter and its 3D region. So if we go into the perspective view and we spin around a bit, we can see, yes, indeed, this is a sphere and these particles are being emitted from it. However, it's interesting that these particles are falling downwards. Because to me, logically, if we're emitting particles from a sphere, they should be emitted from all directions of that sphere. That's why we're using a sphere. So if we select the gravity and then use the keyboard shortcut D to disable the gravity, we see what happens. So the gravity really is what's pulling those particles downwards. So I'm going to use A to re-enable it. Then if we look at the velocity, and the velocity, if you'll notice, is placed before the emitter. and we use D to disable it, you'll notice that it looks like the particles are being distributed in ball-like chunks. So let's run this forward a bit. So do you see what I mean? It's almost like this unit of 100 particles. I know there's 100 particles because I've seen what's inside the emitter here. We can see number of particles is 100. They're being emitted in 100 particle spherical balls, and that also kind of makes a bit of sense because there are 100 particles being generated in a sphere shape per frame. And so this is one frame, this is one frame, this is one frame, and they're slowly being pushed downwards because of the gravity as we scroll across. So what the velocity does before the birth of these particles is it's telling them to be dispersed from its own region. And in this case, these two regions happen to be identical. So if I select this region again, and I go to the top menu and I say View, Hide All Controls, or use Shift-C, we no longer see that sphere. And then if I select the region that is attached to the velocity, and I do the same thing, Show Controls, we see another red sphere. They look the same. They probably have the same dimensions and everything, but they work differently because the particles are being emitted in this case from the sphere, and in the case of the velocity, they're being forced forward in that shape. But because there's the gravity, not only are they being forced out from the surface of the sphere, they're being then pushed downwards. So if I re-enable the velocity, we can see it looks the way it should. The way it actually should look, though, is this. Like that. So that makes sense. Emitter puts them out in ball-like shapes. Velocity pushes them out from the sphere because it's connected to a shape before they're even born. So as soon as they're born, they're popped out of the sphere and pushed forward from the sphere. The gravity is what pushes them downwards. The move particle is what actually moves them, because otherwise, I'll show you, if we disable, we get that effect. They're bunched in that ball. Let me zoom in to show you. And let's disable that that sphere. So it's just a bunchy ball that keeps having more and more randomized particles, 100 per frame actually, being added to its ball-like shape. So because we move the actual particles, they're now flowing downwards. And then lastly, if we scroll upwards, we can see, should zoom out this time, maybe it's even better seen in the camera view, that they disappear right here. So if you think about it, when we create a particle system, most particles just continue onwards or outwards into infinity. But these ones disappear, and that's because of the sink. So if I disable the sink, you'll see now they go down forever. And the sink itself also has a region here. So let's take a look at what that looks like. It actually happens to be a cylinder. So anything created within the cylinder remains seen in the camera view, and anything that, if we enable the sink, exits the cylinder, then disappears. And it's a little hard to see here in the camera view. If we go to the perspective view, maybe you can actually see that it sits on this grid plane, and that's where the particles are being cut off. So that was just a general overview of the way that these action modules, which we know are read right to left, are read and what they do before they hit the composite and the baker and the visualizer. I didn't go into the layer properties of each of these, but I will in a more complicated example. So let's exit this group, and I'm going to actually delete it here. And now let's add a group that's very similar, or a template that's very similar, but actually more complicated, so we can go over a lot more modules more specifically. And that happens to be the Confetti group right here. So I'll drag and drop it in, and I'll connect it to my composite, and we see it now here in the camera view. Also, I'd like to point out that the modules that I'm going to discuss in the Confetti group, so if we go into the group, we can see an explosion of colorful modules. All these modules exist in their own tab in the module library, and it's right next to the particle examples, which once again are the particle templates, and it's in a tab called Just Particles. So some of the ones that we already saw, such as the system composite, the visualizer, the sprite emitter, the planar region, the move particle, the baker, etc., all can be taken as individual units from the module library from the particle tab. So let me move the playhead back to frame 1. Actually, I'm just going to collapse the data view here, and let's take a look at what this effect looks like. So that's pretty neat. There are two new things working at play here that we haven't seen before. The first being that a sprite is actually being used, and we know this because these are not just white dots, but they're colorful squares and circles, and also that a bounce plane is being used. If you noticed, as the confetti hit this floor or this plane, a lot of them, maybe we have to zoom in to see it, are actually bouncing off this floor in a very natural way. So we know that some degree of physics is being applied. So the first thing I want to show you is what the sprite looks like in this case. So if we go to the drawing view and we scroll down, I can tell that it's this one right here because there are several different drawings on the same drawing layer. So it might be a good idea to rename this as confetti drawing or something like that so you know. And then if we scroll across, we can see that they're just squares of different colors. And then I think eventually we hit some circles of different colors. So that's all that is. And if we remember back to our types, this here would be type 0 on frame 1. And this on frame 20 would be type 1. And this other drawing here, I believe, yes, is the bounce plane. So it's just a rectangle with some decorative black dots going around it. Okay, so now let's take a look at the network view. And let's work from right to left, as that's the way that these action modules are being read. And if there's anything connected to the action modules, then I'll also discuss them as well. So the first one we saw was the move particles. And we actually already went into layer properties in the first video. So we're going to skip that and then move on to the velocity, which in this case also has a peg. So for this module specifically, I'm going to click on its yellow box to bring up its layer properties as a floating window. And you'll see why, because here we can't see any of the fields for the options that are listed because they're so far removed from the actual option title. But that's really not a big deal. So for me, I feel like the velocity module is actually mislabeled. I think it should be called the initial velocity, and that's because it always defines the initial velocity of the particles at birth. So it's always placed before the emitter on the particle system composite. So the first option is the trigger, and this is once again the binary 0 or 1 to turn this module on or off. And because there is a function button here, we can also animate that on and off switch. The second is the velocity type. So right now it's set to random cone, and it really does look like it's spraying out of a cone. But let's take a look at some of the other type. So there's use input shape, and we've seen that before. We've seen a region attached to the velocity. There's constant speed. There's interpolated speed, random in all directions 2D, random in all directions 3D, random in cone, and random in 2D pi. So the rest of these options below pertain to which velocity type is selected from this drop down. And to take a look at what the velocity type looks like in the camera view, once again, we can show control. So I'm going to go to the top and say view, show, control. And so we see a cone here, and it might be actually more obvious in the perspective view. Okay, so it looks something like this. So the first option that we have here is bilateral, and bilateral means that it'll emit from both sides of this shape. The direction or normal for random in all directions 2D, so that's this option here, random in all directions 2D, allows you to define the X, Y, and Z influence of a region. So if the X and Z are set to 0 and the Y is set to 1, then really the influence is being shot along the y-axis here, which is the up and down. If you remember, the x is this way and the z is going back into space this way. So if we wanted these particles to be sprouted in a 45-degree angle, we would have to change the x value here to 1 as well. And that would give an equal influence on both the x and the y-axis, which would then force us into a 45-degree angle. The speed pertains to the interpolated speed velocity type. So it would interpolate between the minimum and maximum values, and you would enter those values here. So deviation from direction has to do with both the cone and the 2D pie, so anything with angles. And in this case, you can change the degrees here to rotate the cone. So you can make it more like 90 or 45, for example, to change that shape. So I'll set it back to 30 the way it was. Okay, so let's move on to the next module, which is the size. So I'm going to click on that. And what we're looking at here is the actual size of the particles and animating them over time. So as usual, we have the trigger, and then down here we have the size type. So we have constant size or use input shape. So it's currently set to the constant size, but if you use the input shape, once again, you would have to connect a shape to the size module. The shape would then determine the size of the particle. So let's go back to constant size. And here you can then decide what that size would be. And in fact, you can also apply a function so that the size increases or decreases over time. And once again, you can always experiment by going into the camera view and changing this value to something maybe ridiculous. You can see how huge that is, just so you have an idea of what each function does. So now let's look at the rotation velocity. And once again, this should probably be named the initial rotation velocity. So just like the velocity, it would never go after the emitter, but always before. It needs to be read before any of these particles are born. And you've probably already deduced from its name that it controls the actual individual rotation of each of these drawing objects on the sprite. So as usual, we have the trigger here at the top, and then we have the axis type, which will determine the rest of the properties below. The first one is interpolated axis. There's also use input shape and constant axis. So if we use constant axis, it's going to rotate the particles around the same axis, not a singular axis in the center of the mass of particles, but the axis that each individual drawing has. And this relates once again to its 12-field grid. So if we go to the drawing view again and we look at an individual particle and we turn on the grid, what it's looking at is this right here. So this would be its y-axis, this would be its x-axis, etc. And that's where it's taking the rotational information from for each individual particle. So if we have the constant axis selected, then only the axis 0 options apply. So as you can see, the axis 1, x, y, and z have been grayed out. And what we can do here is change the influence just as we saw with the velocity. So you can either use the value of 0 or 1. So 1 means that the influence is coming from the z-axis and there's no influence coming from either the x or the y. And you can always change that by changing these values here. If you then select interpolated axis, then all of these particles will individually rotate between two interpolated axes, and these axes are axis 0 and axis 1. And once again, you can change the influence for the x, y, and z values for either 0 or 1. Then if you go use shape input, obviously you would have to attach a shape module to this rotation velocity module, and then the particles would rotate perpendicular to the shape that's been selected. And then here we have the speed in degrees per frame, and you can enter a minimum and maximum value. So this is the maximum value that a single particle can rotate in one frame. So it can only rotate 20 degrees. So for example, if we put 360, there would be some pretty whirling pieces of confetti coming down because a 360 is a pretty fast movement just for one frame. So we already took a look at the emitter here. And once again, this time we actually have a drawing or a sprite that's attached to the left port of the emitter. And if we go to the rendering tab, we can see the rendering strategy is actually use particle type. We have a 3D region attached to it, which I don't think we did look at. We looked at planar region, but not 3D. So let's take a look at that. Once again, from the type option, you have several from the drop down: box, cylinder, cone, sphere, or an image, in which case you would have to plug an image into the left port of the 3D region. So if we actually show controls, we can see the different shape types, so sphere, box, cone, cylinder, etc. So that was the box. So we'll go back to cone. And depending on which type is selected here, certain options become enabled for the size and for the radius. So in the case of the cone, it's really just this height here from the apex down to the largest part of its diameter. For example, if it's a box, then you get all three because you need the height, width, and depth, etc. And if it's something round like a sphere, we have the radii, the min-max, that become enabled as opposed to the height, width, and depth. So that makes, I think, a pretty fair sense. So the peg in this case is what's moving the 3D region. So if we select the peg and then use D to disable, we'll see that the sphere, or the point of origin where the particles are being emitted, drops down lower. And my guess is that it dropped back to the 0, 0, 0 origin point in 3D space. So it's even difficult to see from here, but I'm pretty sure it's at the origin point. And if we look at this peg here that's been selected, and we go to the transformation tab, we can see that it's been moved positively up the y-axis. That's what the north stands for. So if we then re-enable this peg, we can see that in fact it's just been pushed upwards again. So the next module to look at is the gravity module. And you'll notice that now we're looking at the modules that come after the emitter. So it looks like gravity is one of those modules with the layer properties that are partially hidden. So I'm just going to click on this yellow square again to bring it up as a floating window. So once again, we have our trigger. Then we have the option of even applying gravity. So if we don't apply gravity, all the particles will fly out from its point of origin in all directions, which in this case would be a sphere. If you do apply gravity, you should choose which direction you would like to apply it in, even if it's by a decimal increment. So because we have a negative 0.1, obviously it's being pulled downwards along the y-axis. If we had positive 1, it would be shooting upwards. And of course, even though it's called gravity, you can have the particles move in the x or z direction as well. So x being from left to right, and z being forward and backwards, and of course y being up and down. So apply gravity between particles, so relative gravity. If you check this, then the force between particles will increase their gravitational pull. Relative gravity magnitude means that the more you increase this value, the stronger the pull will be in whichever direction you chose. Relative gravity epsilon is the force of repulsion between particles. So if the particles touch, they actually increase each other's gravity. So it's always good to have a little bit of a force between them so that they don't actually touch. And the relative gravity maximum distance is the distance that you put between particles where their gravity will no longer affect each other. So I'm going to close that. So the next module is the bounce module, and this has to do with this plane right here, and that's why we see a few things being plugged into it. So we have the region, the planar region module, which is attached to it. However, we have the actual drawing as well, and the difference is the planar region defines where the bounce will occur, but it's not something visible that we can see. So that's why we put in a drawing, probably at the exact dimensions and at the exact angle of this planar region, so that when the particles hit it, it's something visible that we can actually see. And this peg probably just moves it into place. So I'm guessing it would have again been drawn in the center origin point between the X, Y, and Z axes. And now it's probably been dropped down lower. So let's verify that. Yes, on the y-axis, we can see that it has a south value, which means it's been lowered. And we can also disable that to verify, okay, it's been lowered and flipped. And then the reason that the drawing is down here is because it just needs to be attached to a peg and then attached directly into the composite. It doesn't need to be attached to the system particle composite. However, like I said, we want it to move, and by move I mean rotate, scale, and move position with the planar region that defines the bounce plane. So that's why they're attached to the same peg. So if we select the bounce, we only have a few options here. We have friction, resilience, and cutoff speed. So the greater the friction is, the less slippery the surface will appear. So for example, if you have a granular surface such as, let's say, roofing tiles, even if something hits that roof, it's not going to slide off as if it were like a plexiglass sheet. There is some grip, there is some grit. So if you increase the friction, you'll see that when the particles bounce off that plane. So the resilience is what makes the particles bouncy. So a small resilience will let the particles bounce once and then just roll away in whatever direction the plane is tilted. If the plane is flat and has a high resilience, it's just going to keep bouncing in place. The cutoff speed is what determines the arc of the bounce, and if you have a tilted surface, that will also increase the arc. So it's those two factors. So if we look at the planar region, which we've already looked at before, once again, it just has the dimensions of whichever shape is selected from the shape type. But I'll refer you back to the first video if you want to go more into the details of the planar region. So lastly, we have the sink, and it only has two options, and that's to invert it. So if you remember in the example I just showed you before, anything that left the sink region disappeared, you can invert it so that anything that touches the sink region will disappear. So in this case, this region is a box. We can make it appear in the camera view, so it's a pretty big box. So whenever a particle escapes from this box, it disappears. And if we inverted that, then it would be the opposite. We could always invert it and bring this down lower so that as soon as they dropped off the floor and into this box, they would disappear. So the last thing I wanted to mention, and maybe we should go to the camera view to see it, and I'm just going to reset my view here and play this for you once again. Okay, you can see that there's multiple generations of this confetti spraying, but the particles aren't pouring down the way they were for the previous example. And that's because of the maximum number of particles defined in the particle baker. I believe in this case that it's set to 500. So if there's a 100% probability that 50 particles will be generated per frame, then by frame 10, all 500 particles would have been generated. However, because the particles disappear after leaving the sink region, it's as if they did not reach the defined value for the maximum number of particles set in the baker. That's the reason why they continue to generate in order to endlessly reach that cap of 500. Anyway, I just wanted to point that out. So we're done looking at this particle system, so I'm going to go back to the top. And I actually think we have time for one more so that I can show you two more modules. And that would be both the kill and the wind friction module. And for this, I'm actually going to grab the fire particle effect template. Actually, maybe I'll do it from the top. since it'll attach right away. Okay, and let's also disable the confetti so it doesn't get in the way. So there's our fire. And it actually doesn't look like it's anything too spectacular to look at from this view, but if you go into the render view mode, there we go. It actually has a nice kind of glow, and it does look like a very nice painterly glowing fire, as it should. So don't let this version of it fool you. So let's go inside the group, and once again there is a fire peg on the outside of the group, but we're more concerned about what's going on in the inside. And several of these modules look familiar, obviously, the velocity, the emitter, the 3D region, etc. Let me just back out here a bit. But the two that we haven't seen yet are the kill, as I mentioned, and the wind friction. So you might be wondering why the kill is in front instead of at the end, because you might think, well, as all of these modules are being read right to left, then don't you want to kill the particles at the end? Well, in some cases, no, you don't. And let's explore the kill module so that I can explain why that might be. So the first option that we have is the trigger, as usual. The second option we have is kill younger. This option is used in very specific cases, and it's usually used when there is a function attached to the value for kill younger. An example would be is if you have an explosion and all of a sudden you might want the youngest particles to die out maybe faster than even the older particles. So that might be one instance where this might be applicable. The more common setting to choose is kill older. So kill the oldest particles that are being generated. And in both cases, you have a field where you can enter that age. So when we enter a value of 40, we are giving the value of the 40th frame. And the reason that the kill module appears before the emitter is because in this case, you have to know when these particles are going to die even before they are born. So the next module I wanted to look at was the wind friction. So as usual, we have the trigger at the top, and then we have the amount of influence or dampening that the wind will have on the various axes, so the X, Y, and Z. If you have a smaller value, so less than 0, I think it actually dampens the effect. And if you have a positive number, it increases the wind friction effect. Then you have the min-max speed values. So if there's a particle moving slower than the minimum speed, then it won't be affected by the wind friction. And if there are particles moving faster than the maximum speed, then they too will not be affected by the wind friction. So that's it for the tutorial, Particle Effect Modules and Templates Part 1. Stay tuned for the next tutorial, Particle Effect Modules and Templates Part 2.